Well, we have another question here. The question says that determine f prime of x from the first principles if it is given that f of x equal to 4 minus 7ax. Now, okay, I'm gonna write the question here, 7.1. We're looking for f prime of x. And then f of x itself is 4 minus 7x. From the first principle implies that, f prime of x is equal to the limit, okay, of h approaching 0 of f of x plus h minus f of x, okay, all over h. Now, I prefer to work out the numerator. Actually, let's first work out f of x plus h, and then we're going to minus it by f of x, and then we divide by h, and then we're going to put in the limits, okay, to work out the derivative of the function. Now, f of x plus h means wherever we have x, we're going to substitute x plus h, like here. Initially, f of x was 4 minus 7x, right? So instead of me writing x, I'm going to write there x plus h, okay? And then if we simplify this makes like 4 minus 7x minus 7h, okay? And then that's f of x plus h. Now, f of x initially was given by 4 minus 7x. I'm going to do then f of x plus f of x plus h minus f of x. So we complete here by 0. Now let's do that. So we have 4 minus 4 with 4. Negative 7x minus makes plus. Okay, this also will 4. Okay. So, and this will be just equal to 7h. So this is the numerator of this fraction, and I'm going to divide this by h. So now if I do f of x plus h, excuse me, minus f of x all over. Now I'm going to divide this by h over h. Okay, it was here 7h, so I divided also by h. Whatever I do on the left, I must also do on the right. Okay, I divide by h, and then we can simplify h and h here. And then here, this is just going to be equal to 7. Okay, now if I put in the limits, then, okay, the limit h approaching 0, there is no any h here, so this is the final answer. The answer is just going to be 7. Okay, I don't need to put I can put the limits here, h with h approaching 0. I put the limits there also. Okay, let's just do it. This will be the limit of h approaching 0 of f of x plus h minus f of x over h equal to, I'll put also the limit over there, h approaching 0, and then of 7, right? So this would be just, the limit here won't affect the 7 on anything because there is no h here. So therefore, the derivative f prime of x is just equal to 7. That was question 7.1. Now we're going to do the following question, which is question 7.2. The question says, let's determine dy dx if y equal to 4x to the power of 8 plus square root of x to the power of 3. Now I'm going to move about this way. (7.2), we're looking for dy dx. Okay, if y equal to 4x to the power of 3 plus square root of x to the power of 3. No, to the power of 8. Okay, let's write it a little bigger. So it's going to be like if y equal to 4x to the power of 8, okay, plus square root of x to the power of 3. Now, to differentiate a polynomial, we're going to differentiate each term of the polynomial, okay? Following this formula, a x to the power of n, okay? This derivative, this will be equal to n times a times x to the power of n. And then before doing this, sometimes questions like that are difficult to solve, to differentiate the way it is given. We need to transform the functions following some law of differentiation, okay? So now, like for the square root here, following the law of exponent, I meant to say, so, you know, we have a law that says that the nth root of a to the m equals to a to the power of m over n. Okay, so now we need to be careful when we don't see any indices here on the radical sign. Okay, this means that the indices here is just 2. So now I'm going to transform the function. So y will be 4x to the power of 8 plus x to the power of 3 can be written as x to the power of 3 over 2. Now, remember that there is a coefficient in front of the x, it's just 1. Now, if I need to differentiate, then to work out dy dx, this is like, I'm going to follow this law of, this formula for differentiation. Over here, if I want to differentiate this term, my a is 4 and then my n is 8. So this will be 8 times 4 times x to the power of 8 minus 1 plus 3 over 2 times 1 times x to the power of 3 over 2 minus 1. And dy dx would be equal to 32 x to the power of 7 plus 3 over 2 x to the power of a half, okay? And then dy dx will be equal to 32 x to the power of 7 plus 3 over 2 square root of x, okay? You remember those laws can be worked forward and backward as well. So we can write x to the power of a half. So m is 1 and 2 is n, the indices of the radical sign. So if you don't see any symbol here, meaning the index is just 2, okay? And then the exponent is 1. So which was like square root of a to the power of m is just a to the power of m over n. So 1 over 2. Actually 1 over 2. Square root of so it's like that way. But I don't really need to write the indices and exponent 1, so I can just leave it. I can just leave it like that. So this is the derivative of this function. Okay, and then the next will be question 7.3. Let's see 7.3. The question says, let's see here 7.3. The question says that given y equal to ax squared plus e, determine dy dx and determine dy dA. All right. Now, we have like y is given by ax squared plus e. Okay. So 7.3.1, we're looking for dy dx. Now, if I need to work out dy dx, it means I'm gonna use this formula again. The formula that we see here, this will be dy dx over here, A is still A, and then N is 2. So it's going to be 2 times A times x to the power of 2 minus 1. And then A here is a constant. The derivative of all constants is just 0, okay? The derivative of a constant C is equal to 0. It's given. So this is going to be plus 0. And then this just dy dx will be equal to 2ax. Okay? And then 7.3.2, we want to work out dy over dA. Okay, that's what the question says. This means differentiate the formula, the function y with respect to a now, not with respect to x. A is the variable. Okay, so what can I do here? Remember that now x squared is like my coefficient. I prefer to transform this equation. I'm gonna write it this way: y equal to x squared a plus a. I'll do that because the variable is always comes after the coefficients. Okay, when we differentiate with respect to a, a is the variable now for differentiation, and x squared is just a coefficient. Okay, x squared becomes it's like something like 2, like 4, something like that. Now, to differentiate this, my a is x squared, and then my exponent here is just 1. Here also my a will be 1, and my exponent will be 1. Okay, so following this law, dy dx, dy dA will be equal to 1 times x squared times a to the power of 1 minus 1. Okay, plus 1 times 1 times a to the power of 1 minus 1. Okay, so this is the same law of differentiation of a derivative that apply here. Actually, I meant to say n minus 1, I forgot. N minus 1 there, yes. N minus 1. And then this will be dy over dA will be equal to 1 times x squared is x squared. And then a to the power of 0 plus 1 times a to the power of 0 dy dA will just be x squared plus 1. Okay. And then, thank you. Oops, I think there's another question, 7.4. 7.4, let's see. Oh yeah, there's another one. 7.4. Okay, here the question says that the curve with expression y equal to x plus 12 over x, okay, passes through the point A. Determine the equation of this of the line perpendicular to the tangents to the curve at A. Okay, I prefer to read it over. The curve with equation y equal to x plus 12 over x passes through the point A. Determine the equation of the line perpendicular to the tangents to the point A. All right, that sounds interesting. Let's just move the board over here and then do question 7. Question 7.4. So we're looking for the equation of the line perpendicular to the tangent to the curve. Okay, there's a certain line. I don't know the line. Let's call the line okay, a certain line. So why I can call the line, I can give the line the name. Okay, let's say the line is n. Okay, y equal to the straight line mx plus c. Okay, and then the curve, we have also the curve here, y equal to x plus 12 over x. Now, this curve passes through the points A, which is the points 2B. Now, they say that this line here, the line here is perpendicular. The line N here is perpendicular to the tangents of the curve. Okay, so how can we do this? Okay. We know that because the two lines are perpendicular, okay, it means that I want to say here the conditions, okay, because the line N is perpendicular to the tangents line. This means that the gradient of the line N must be equal to 1 over the gradient of the tangent, okay? Or sometimes they say the product of the gradients will be equal to -1. Yeah, negative here. Yes, it's like that. Now, this is one condition. And another thing we know is that the gradient of the tangent line must be equal to the derivative of the function, okay? Of the function, or in this case, of the curve. And also, if the point A lies on the curve here, it means we can find B by subbing in the value of 2, okay? So B will be the Y value. We give a sub the point A, okay? So I want to say here sub A, which is 2B sub A. On the curve, this will be like, it's going to be, okay, it means like wherever I see, so B is there, okay? And then B for Y. The Y value will be B, and then the X value will be 2. So I sub 2 there for X. Okay, and then this will be equal to, this will make B equal to, that's gonna be 2 plus 6, so B equal 8. So the point A is the point 2, 8. First thing, we got the point A. Now, we can calculate then the gradient, okay, of the tangent by saying that this is the derivative of the function. So the curve is given by y equal to x plus 12 over x, right? Now, if I need to work out the derivative, let's first transform this. This is like y equal to x plus 12 x to the -1, okay? Now, the derivative f prime of, or dy dx, same thing, f prime of x will be equal to, following the same formula we used earlier. Remember that over here, the coefficient is 1 and the exponent is 1. So I'm gonna write here 1 times x to the power of 1 minus 1, okay? Plus, again here, -1n, the exponent, times the coefficient, which is a, 12, and then times x, -1 minus 1 there. And then this is just equal to, okay, because all this makes 0. So we have like 1 times 1 times 1 again, because x to the power of 0 is 1. That's 1, plus, not plus, but minus 12 x to the -2. Okay, I can continue calculations here. This will be excuse me, f prime of x will be 1 minus 12 over x to the power of 2 if I apply the law of exponents. Remember, the law of exponents says that a to the -m is equal to 1 over a to the m. So we have like a negative exponent here of -2, or the negative exponent here, and then this can be written as 12 over x squared. Okay, so if I sub in the point 2, Okay, because tangent is where it touches the graph at a certain point. It touches the graph at this point. When x is equal to 2, I can find the gradients of the tangent, okay? And this will be m of the tangent will be equal to 1 minus 12 over 2 squared, okay? And then this will be equal to 1 minus 12 over 4. 12 over 4 is 3, so this means that m tangent will be equal to 1 minus 3. So m tangent will be equal to -2. So we got the gradients of the tangent line. Now we said the line perpendicular to the tangent must be equal to -1 over mt. So therefore, mn, the line perpendicular to the tangent, will be -1 over -2. Okay, so this will be mn will be equal to a half. Then we can write the equation of the line. The equation of the line will be, okay, you know that the equation of the line is given by the formula y equal to mx plus c, okay? So now the line perpendicular to the tangents will then be y equal to a half x plus c. Now I want to sub in the points. The points because this point 2b is now the point 2a. I sub here the points 2 for x and then 8 for y. This will become I want to sub 8 here for y. Okay, 8 for y, and then this will be equal to a half, and then 2 for x plus c to find c. I'll sum 2 there for x, and then this is just 1, so it's going to be like 8 equal to 1 plus c, and then that makes 8 minus 1 equal to c. Y will be equal to then the gradient is a half x plus 7. Okay, because it's 7 now. Thank you.